Take a close look at a suspended drop of water. Like the air we breathe, we assume this liquid is electrically neutral. In physics, calling an object neutral simply means it holds a strict mathematical tie. The total positive protons inside that drop are perfectly balanced by equal negative electrons. But a net zero charge overall does not guarantee a zero electric field. The internal arrangement of those charges creates hidden electrical forces that dictate how the material behaves. We map this using an electric dipole, a pair of equal and opposite charges, positive and negative Q, separated by distance 2a. Their fields don't completely cancel. Along the axis, the resultant field pushes outward. On the perpendicular equatorial plane, it points oppositely. The mere separation of these two balanced charges gives birth to an invisible, highly directional electric field aura surrounding the neutral pair. To see how this dictates reality, we have to shrink these abstract point charges down to the molecular level. Look at carbon dioxide and methane. These are highly symmetrical molecules. Carbon dioxide forms a straight line, while methane builds a perfectly balanced tetrahedron. Because of this geometry, the exact center of all their positive charges and the exact center of all their negative charges perfectly overlap at the exact same point in space. Our separation distance, 2a, is 0. As this equation shows, without physical distance between the opposing charges, the inherent dipole moment, denoted by the letter P, is 0. Molecules like these are nonpolar. They only develop a temporary, induced dipole if an external electric field forcefully stretches their internal charges out of alignment. Water, H2O, acts completely differently. It has an asymmetrical, heavily bent V shape. Thanks to that sharp bend, the center of its negative oxygen charge and the center of its positive hydrogen charges sit in different physical locations. There is a built-in gap. This spatial separation means the water molecule permanently maintains the opposing positive and negative dynamic we mapped earlier. Water is a polar molecule. It possesses a permanent electric dipole moment, making every single molecule act like a tiny, continuous electric compass needle. In its resting liquid state, a glass of water is a chaotic jumble. Billions of these microscopic dipoles are tumbling randomly, pointing their electric fields in every possible direction and canceling each other out on a macro scale. But watch what happens when we sweep a uniform external electric field across this environment. The external field exerts a rotational force, a torque, on every single permanent dipole. As we see in this equation, the torque is the product of the dipole moment crossed with the external field. The result is instant. Billions of chaotic arrows snap into perfect alignment. This collective alignment is what allows neutral matter to react to electricity. It's why a plastic comb can lift neutral bits of paper after being rubbed. The comb's field polarizes the paper, forcing its internal dipoles to align and create an attractive force where none existed before. When we see a spark jump from a synthetic sweater or watch water droplets cling to a surface, we are seeing the macro-scale consequences of these tiny asymmetrical gaps. This microscopic separation of charge is the invisible engine dictating how everyday matter interacts with the universe.